In this video, we will talk about function pointers in C programming. The first thing that we must think, why do we need a function pointer? While we can simply call a function from anywhere. Let's think about a scenario where we are writing an interrupt routine from which we need to call user-defined APIs, and this user-defined APIs could be anything. So we are not going to change our driver code for the interrupt for every user application. So we'll fix our interrupt routine and we'll use function pointer there, and application software writer will update that function pointer and interrupt routine will call it. This problem can be solved using callback mechanism. In callback mechanism, a reference of a function A will be passed to another function B, from which function A will be called back, means executed. The topics on which we will discuss in this video are definition and basic concept of function pointer, declaration, assignment and dereferencing of a function pointer, and we'll see three use cases. In the first use case, we'll see simple implementation of function pointer. In use case 2, we'll see callback concept, and in use case 3, we'll see function pointer array. Let's see the first topic, definition and basic concept of function pointer. Is it like a normal variable pointer or is it different? A variable pointer points to the base address of the memory location of assigned variable. To understand this concept, we'll see memory layout first. Here, we'll only focus on code segment, initialized data segment and uninitialized data segments. Variables are stored either in initialized or uninitialized data segment, and executable instructions are stored in code segment. A pointer which has to point to the memory location for a variable will point somewhere in initialized or uninitialized data segment, and a pointer which has to point to the memory location for executable code will point somewhere in code segment. So a variable pointer will point somewhere in initialized or uninitialized data segment. A function pointer is similar to the normal variable pointer, which will point to the base address of the function. A function is a set of executable instructions which is stored in code segment. This function is having 5 instructions. Instruction 1 is stored at lowest memory location. So if a pointer has to point to the base address of the function, means it has to point to memory location where instruction 1 is stored. Now we'll see the declaration, assignment and dereferencing for the function pointer. Let's see the declaration first. In declaration, we need to take return type of the function pointer name with asterisk key operator, and data types of argument. Next, we'll see how to assign the address of a function to function pointer. It can be done in two ways. First way, using ampersand operator. Ampersand will give the address. Second, without using ampersand operator, function name itself will give the start address of the function. So directly we can assign function name to the function pointer. Next, we'll see the dereferencing. Dereferencing means accessing the memory location that pointer points to. Dereferencing also can be done in two ways. If we have assigned reference of a function using ampersand operator, dereferencing can be done with asterisk key operator, and we have to pass the arguments to it. And if we have assigned without using ampersand operator, then dereferencing can be done without using asterisk key operator, and we have to pass the arguments to it. Now we'll see the use case with examples. In use case 1, we'll see simple implementation of function pointer. Take add function which will add two numbers and return the addition result. Then in main, declare a function pointer, assign base address of function add to the function pointer, and lastly do the dereferencing and print the addition result. Now we'll write the code for this. Has include stdio.h. Next, we will define add function, int add, which will take two arguments a and b, and it will return addition result. In main, let's declare a variable val of integer data type, declare a function pointer. Our return type is integer. Take function pointer name funcPTR. Argument type is integer for both. Assign address of function, add to the function pointer. Function PTR equals to %add. Now we'll do dereferencing. Here we had used ampersand operator. So for dereferencing, we need to use asterisk key operator. Val equals to add with asterisk key operator and pass arguments 1 and 2. Print the addition result. Let's save this code with the name taste.c. Taste.c is present now in the directory. Compile the code using gcc command, gcc taste.c, and output will be stored in taste.exe. Now taste.exe is present in our directory. Let's run the executable file taste.exe. We got the print addition result equals to 3. Next, we'll assign the reference of a function to the function pointer without using ampersand operator. So we need to do the dereferencing without using asterisk key operator. Let's save this file, compile it again. Let's run the executable code. Got the same print, addition result equals to 3. Next, we'll see the main use case of function pointer, the callback mechanism. To understand this concept, we'll take add and subtract functions. We'll take another function called wrapper function, where we'll pass reference of add or subtract function, and callback function add or subtract will be executed in wrapper function. Create another function subtract, which will return difference of a and b. Create wrapper function which will take the reference of a function in its argument. Let's declare a function pointer in argument, call the callback function and return it. In main, do the addition operation using wrapper function. Val equals to wrapper function and pass the reference of add function, print the addition result. Do the same for subtract. Val equals to wrapper function and pass the reference of subtract function, print the subtraction result. Let's save this, compile the code. Executable file is present now. Run the executable code. We got the print addition result equals to 4, 3 plus 1. Subtraction result equals to 2, 3 minus 1. Now we understood the concept of callback mechanism. The one very important use case of function pointer is interrupt routine. Let's say we are writing an interrupt routine for timer 1, from where we have to call user API. So this user API will be defined by application software programmer. So the application software programmer is not going to write the code for interrupt routine. And we are having one more API to set the user API. Using this set user API, our application software can set the reference of user API. Let's say this user API is either add or subtract, and we can call user API in our interrupt routine using function pointer. Declaration of this global function pointer can be done globally. From user application, we will have to initialize the timer 1, disable the interrupt so that interrupt will not be generated as of now. Set the user API, add or subtract using set user API function. Enable the interrupt. After enabling the interrupt routine will be called on regular interval, in which user API add or subtract will be executed. I am not running this code here because it will take more time to show the demo here. Anyway, it's simple. You can check this at your side if you have ready code for interrupt. Now we will see the last use case, function pointer array. Here We will take same add and subtract functions. Take function pointer array of size 2. Assign the address of add function to first element. Assign the address of subtract function to second element. Call add and subtract functions using function pointer array. Declare function pointer array. Assign the references. Add to the 0th index. Subtract to the first index. Now do the dereferencing. Val equals to function pointer array with 0th index. Pass 3 and 1. Print the addition result. For subtract, val equals to function pointer array with first index. Pass 3 and 1. Print the subtraction result. Let's save this file. Compile the code using gcc command. We got an error. Okay, I missed the array size here. Update this, save it again. Compile it, run, executable file, test.exe. We got the print, addition result equals to 4, subtraction result equals to 2.